All right. So I'll talk to you guys a little bit here about the average velocity of a rolling object. So in this lab or activity, you guys are basically going to be measuring various distances and times of an object rolling down a ramp or down an inclined plane of some sort. Now, I won't read directly through these instructions because I'll leave that for you guys, but basically you can pick any round object. You can pick something as small as a marble, or maybe something the size of a golf ball, or if you even want to do like a tennis ball or a soccer ball or a basketball, you can. But just know that you need to somehow measure the distance and also get a time of the object as it rolls. So if you're trying to keep this compact or something that's a little bit smaller, I recommend using a small object. So if I look at the data table, the data table kind of tells what data needs to be collected. So first thing here is the length of a ramp. So you guys can create a ramp, you can build a ramp, or you can use something that you got around the house. For example, maybe you can just find an old piece of wood that's got a groove in it. Maybe you got some sort of a plastic or a metal ramp at home that you can use. Maybe it's like some old toy like a slot car or whatever it may be. And then of course whatever object it is that you're going to roll. So the problem is asking, how will the slope of the ramp affect the velocity? Well, the slope of the ramp has to do with the steepness of the ramp, so how high you lift one side of the ramp. So things to consider: your overall length of the ramp, and you guys will use your own measuring devices, but you're probably going to want it to be at least approximately that length. Now, you could be using rulers or a tape measure or something a little bit different, but either way you still need to measure the total length of the ramp and the height of the ramp. So determine what that is going to be. If you guys are feeling adventurous and you want to take this to a much larger scale, you could do this outside. If you had a long hill or like your sidewalk or someplace outside and you wanted to roll an object, you could do that. The only thing that you have to consider is you still need to measure the total change in height. So if you use a small object such as a ramp, it's pretty easy to just lift up one end of the ramp and either set a ruler or a meter stick or something there to figure out the height. If you're actually outside and you're rolling something down a hill, we need to know how far it actually falls, and you may have to find multiple hills for multiple steepnesses. But if you wanted to make this as a larger scale, using plywood or something outside and build a ramp that you can adjust, that would be great. But my recommendation, keep it simple, keep it compact, keep it inside. Once you determine the ramp you're going to use, you can measure that length, because the length of the ramp will always stay the same. So if I'm going to be using this ramp and I want to determine where the start and finish is, I can pick, in essence, any distance that I want. If I want the length of the ramp to be 40 centimeters, I could just mark off maybe with a piece of tape or a pencil, set it at 40 centimeters, because the length that the object actually rolls will not change. The variable that you are changing is the height of the ramp. So the height of the ramp is going to be from one tail end, whichever end you're actually lifting. Then you're going to do 4 different heights, and for each height you're going to be measuring 4 different trials. And the trials are just rolling the object and timing the object. So you do it 4 times from each height and then change the height. People do get carried away trying to get to too extreme of a height. The problem if you get the height of the ramp really, really tall at an extreme angle, when you go to roll the marble, it's way too fast to actually time accurately. So my recommendation is to definitely keep the ramp as low as possible while the object still moves. So I could do one trial at 5 and 10 and 15 and 20. So your highest trial could maybe be at 20 centimeters. You don't have to change the increment by much. You could go up 1 or 2 centimeters at a time. That would be perfectly fine. Once you've done this, you can calculate your time average. Take all 4 trials, add them up, divide by 4. And once you've found the time average by dividing your numbers out, you can go and calculate average velocity. And remember, average velocity would be distance divided by time. Keep in mind your distance is the length of the ramp, not the height of the ramp. This is how far the object rolled. It's always going to roll that same distance. You're doing distance divided by average time to get your average velocity. Then if you flip over to the back side, you'll see that there's a graph. Now in the directions it says for you to make a height versus velocity graph. So how tall the ramp was versus how fast the object was going. So you can do height versus velocity or velocity versus height. That I leave up to you. But bottom line, there should be at least 4 data points. You could have one be at 0, 0, which would really give you 5 data points, but you have 4 average velocities and 4 height of ramps. So I think we know maybe as the height of the ramp changes how that's going to affect the velocity. So be sure to do that and incorporate a conclusion, and you guys should be good to go. If you have questions, please feel free to let me know, and I'll try to help you guys out. Thanks a lot.